Hello everyone, welcome back to Introduction to AI Systems course. Today we're going to learn a new topics of AI, which is clustering, and especially as one of the clustering algorithms, today we're going to learn a k-means clustering algorithm. Before talking about the clustering algorithm, let me introduce the concept of supervised and unsupervised learning. So the key difference between the supervised and unsupervised learning is that supervised learning is kind of a building a model from labeled data. So this one is very special terminology. And in the case of unsupervised learning, we are kind of clustering from unlabeled data. So maybe you guys maybe heard about the terminology of supervised and unsupervised, but the key difference between the supervised and unsupervised learning is that if the data has some label, then it's kind of a supervised learning, and if data has unlabeled, then we can call it as an unsupervised learning. So let's say here in the last time we have learned about the classification. So to classify the class of the data, we should have some data that has some labeled class. So that means in this figure, the blue one is kind of belongs to the data that belongs to class 0, and the red one is belongs to class C2, and the green one belongs to C1. So that means you have data set of for x1 and x2. So for given x data, you have labeled the y. So for example, for this data, the label of this data is written as 0, so that you can classify this data is belong to the C0. And in the case of this data, this one has labeled of y is equal to 2, so that you have the labeled data. And for this data, this one has the data for y is equal to 1. So by doing so, all the data has the labeled. So it's kind of, when you prepare the data should have some pair. So for given this data, you have a paired set of labeled data, and for all the data set, you have paired labeled. So by doing so, by using these paired data, you can classify the class of the data. So this is one of the core. So by doing so, this is the basic idea of classification. But in the case of unsupervised learning, the data has no label. So the data is unlabeled data. So like this, there is no label. So of course, by just intuitively, we can divide this data into three cluster. But actually, before visualizing it, we don't know the label data. So the only thing that you have is kind of x1 and x2. So you only have x data. So without labeled data. So in this case, we call it as a clustering. So please don't be confused between the classification and clustering. So the basic idea of classification is you have some labeled data, and for this data you just classify the data. But in the case of clustering, you don't have label. You just find some cluster, which is a group, a kind of grouping. So you are just finding some groups that can divide into some clusters. So here the algorithm is called clustering. So that's the key difference between the supervised and unsupervised learning, and especially for classification and clustering. So data clustering is kind of an unsupervised learning problem. So for given data, for m unlabeled example, you just have some x data. So you have m data without a label. Then we need to partitions k. So here the k means the partitions. So the number of group. You can think of it as a number of group. So the goal of clustering is finding some grouping, is kind of a grouping. So the goal of the data clustering is group the examples into k partitions. So let's say for here, maybe we can grouping into two groups of the first group and the second group. So here, instead of saying class, here we're gonna call it as a clustering. So here, let's say we can make two clusters. So the first cluster and the second cluster. So for given m unlabeled examples, we're gonna find some k partitions or k clusters.
So in order to do some clustering, we need to find some similarity. So that means the only information clustering uses is the mutual similarity between samples. That means from these unlabeled data, in order to determine clusters, we need to find a mutual similarity between samples. So let's say for these two data, we can say they share some similarity. So, but in the case of this one and this one, they are we don't. It's difficult to say they have mutual similarity. So a good clustering is one that achieves high within cluster similarity, but at the same time low intercluster similarity. So that means between these within clusters, they should share some high similarity, but for two data samples, intercluster data, they should share a low similarity. And the most intuitive way to measure similarity is kind of calculating distance between samples. So let's say for this within cluster, these two samples, they share a high similarity. That means their distance between these two samples are very close. But in the case of two intercluster, like these two intercluster data, their similarity should be low and their distance is large. So based on this, the k-means algorithm is kind of an iterative way to find best clusters. So let me briefly explain the algorithms. So firstly, we need to initialize these two data samples. So that means for this data, we need to first assume the number of clusters. So let's say for this data, we know that we have two clusters. So let's first start with the case where we know the number of clusters. So the idea is we are knowing the number of clusters, and based on this training set, we first need to randomly initialize cluster centers anywhere in our Rn space. So let's say from this training data set, we first initialize these two cluster centers like this. So as we know the number of cluster is exactly the same as 2, we first find the 2 points of the X, the red one and blue one. And the next step is assigning data into all the clusters. So for that, in the previous step, we know the center of the clusters, and for any data, we need to find nearest centroid. So for this data, the nearest centroid is the red one. So this data needs to be assigned to cluster red. And for this data, the nearest centroid is the blue one. So this data should be assigned to the cluster blue. So likewise, all the data can be assigned to proper clusters. And then the next step is finding the mean within the cluster. So let's say for this red cluster, the mean point, or the mean is this one. So, and for this blue data, the mean is like this. So for this the mean value, the centroid should be moved. So move centroid to mean of all points assigned to cluster K. And so this is the updating algorithm. So this step should be repeated until convergence. So a possible convergence criteria is cluster centers do not change anymore. So after its convergence, or after some iteration steps, the algorithm stops. So by doing so, we can find a proper centroid. So that's it. So after the iterative process, the output is just the labeled C, which is index of cluster centroid, or which we also call it as centers, and also the mean or average of points assigned to cluster is just the output. So after doing some iterations, we are gonna get these two as outputs. So after this process, we can find a proper centroid and also the mean of the each cluster. So by keeping this in mind, let's visualize this process in more detail. So for that, we first consider the case where we know the number of cluster, which is k is equal to 2. So the first step is initializing the centroid. So let's say we randomly select the two centers, which is pointed as the red cross and the blue cross. Then by using these two centers, we assign all the points by measuring the distance between the centers. So like for this red data, this one, the nearest center is the red cross. So this one is assigned to the red clusters. So similarly, all the data are assigned to a proper cluster. Then from the assigned clusters, we need to recompute the cluster centers. So by calculating mean or average of within the cluster, the center should be updated into the mean of this data. And also similarly for the red one, for the blue one, we also need to calculate the mean of within the cluster. So by knowing the center of the cluster, we need to update these two. We need to update the cluster centers. And the next step is just repeating the iterative process. So for the updated these new clusters, we also need to assign all the data into a proper cluster. And then from the updated clusters, we need to recompute the cluster center and iteratively conduct the process. So this one we need to recompute the cluster center again and assign the points again, and again recompute the cluster center again. And as you can see here, when you calculate the cluster centers, the updated cluster centers does not change at all. So that means these cluster centers now converge to some centroid. So that means our iterative process can be ended, and the k-means clustering algorithms now converge and it is ended. So after repeating this process, we were able to now find two proper clusters that can two groups of data. Yeah, so that's it. The k-means clustering algorithms. So from now on, let me summarize our k-means clustering algorithms. K-means clustering algorithm is just basically an iterative algorithm to find some clusters. So for that, we first need to randomly initialize k cluster centroid for the k clusters. So we first need to initialize the centroids or center, and then we need to repeat this process. Firstly, we need to allocate all the data points to clusters centroid closest to cluster centroids. And after assigning all the data points into proper closest clusters, then we need to calculate the average or mean of points assigned to cluster K. So for the calculated mean of points, we are updating the new centroid. Then we need to go back to the first step. So we repeat this process until it converges or the number of iterations stops. So by keeping this in mind, from now on, let's implement this k-means clustering algorithm in Python. So for that, we first let's generate some data to be clustered. So for that, let's allocate the G0 to G2, G0, G1, and G2, which is just random multivariate normal distribution of these two-dimensional space. So by doing so, we were able to generate like these 2 points, and by visualizing it, we now see some data are generated in this two-dimensional space. And the next step is we should know the number of clusters. So for the problem that the number of clusters is given, you can just allocate the k is equal to 3, or in other case, you can just assume that k is equal to 3. So for that, we need to just allocate the number of clusters, and then the first step is just randomly initialize mean points or at the center of the centroid. So as you can see here, the red one is just random points of the initialized cluster, initialized centers of the clusters. And next, we need to conduct the iterative process, which is repeating the process to update the center of the clusters. So for that, let's say for n which could be the number of iterations. So in this case, we're going to set it as 500 times. So for 500 times, we're going to repeat this process. And for I in range m, so that means we have m data points, right? M data points and k clusters. So for all the data, for all m data, we need to calculate the distance of the distance between the x data and the center of the clusters. So let's say the center is like this, and for this data we are calculating the distance. So let's say D0, and this one is D1, and this one is D2. So by calculating D0 to D2, what we need to do is finding the minimum distance. So let's say for this data, the minimum distance is D2. So by doing so, we are just updating this data into D2. So let's say this data, the arg mean of this one is D2. So the arg means the index. So y data would be allocated to y2. So for all the data, we need to calculate all this process, and after doing so, the next step is updating the center of the centroid, center of the clusters. So for I in range k, we need to calculate the mean of the clusters, new assigned clusters, and this data should be updated. So this one is just updating this process and calculating error between the norm. So this one is just doing so, and when you calculate this error is smaller than some criteria, that means the new updated center does not change. Smaller than the when the updated the value is smaller than this value, then the iteration should be stopped. So by using this break, this whole process would be stopped. So this whole repeated process would be stopped whether the number of iteration reaches to the n iter, or the error is smaller than this criteria, or we can say it's converts to some the iteration just converts. And the other way to implement this k-means clustering in Python is just using also scikit-learn. So scikit-learn, as similar to other any machine learning algorithms, scikit-learn provides some very simple code for the k-means clustering algorithms. So for that, we need to import sklearn.cluster, and here we need to import k-means. So the only thing you need to do is just k-means and just allocating the n clusters and just initialize some random state. And by using the k-means.fit sentence, you can train the older model. So that can be, so by doing so, after doing this process, when you visualize this result, you can clearly see 3 clusters are properly grouped. Yeah, so that's it for the k-means clustering algorithms. But as you can see here, there are some remaining issues, which is initialization issues. As we can see in the previous algorithms, k-means is extremely sensitive to cluster-centered initializations. So a bad initialization can lead to poor convergence speed or bad over-clustering. So safeguarding measures is just choosing first center as one of the examples, and second, which is the farthest from the first, and third, which is the farthest from both, and so on. So the idea is just try multiple initialization and choose the best result. So that's the key to avoid the initialization issues. And also the remaining issue is how to choose the number of clusters. So at first I said we need to assume the number of clusters. So when we don't know about the number of clusters, the number of clusters is not given, we need to somehow choose the number of clusters. So how to find then how can you find the number of clusters? So the idea is very simple. So when you add the another clusters and it does not give any much better modeling of the data, then that is the number of clusters. So one way to select k for the k-means algorithm is to try different value of k and plot the k-means objective versus k and look at the elbow point in the plot. So let me explain it in more detail with examples. So the idea is just you need to increase the number of clusters. So from I is equal to 1 to 11, you just need to increase the number of clusters from I is equal to 1 to 11. So by fitting this model, you can just save the cost function, and then when you plot this, you may obtain this result. That means the x-axis is the number of k. So when the cluster 1 is 1, the error is about 7,000. And when the k is 2, the cost function decrease to like 1,500. And when k is equal to 3, the error also keep down to 500. But when you keep increase the number of k, this does not change at all. So from that, we can conclude that here the proper number of cluster could be the k is equal to 3. So here, when you plot this, there are some points where it does not change at all, and here we call it as elbow point. Yeah, so that's it for k-means clustering algorithms. So we know that what the k means and what the means mean. So the k is just basically the number of clusters, and means is just meaning the average within the clusters. So just by calculating the means within the clusters, we can find the centers of the clusters, and by doing so, we can simply grouping the data. So k-means is very simple and intuitive algorithms to group all the data. But at the same time, it also has some limitations. So let me explain some limitations in more detail. So firstly, there could be some cases where it is hard to assign the points to clusters. So for that case, there could be some cases. So firstly, a point either completely belongs to a cluster or not belongs at all. In this case, it is difficult to assign points to clusters. And also, no notion of a soft assignment. Here, soft assignment means a probability of being assigned to each cluster. So here, the Gaussian mixture model or fuzzy k-means allow soft assignments. So in this case, it is difficult to assign the points to clusters. And the second limitation is the k-means algorithm is sensitive to outlier examples. So here, as we measure just k-medians, as we measure the k-means, so it could be some, if there are some, maybe like here, maybe here, some outlier here or outlier here, then could be a result in bad clustering. So here, instead of it, a k-medians algorithm could be a alternative for data with outliers. And also, k-means clustering algorithms works well only for round-shaped and of roughly equal sizes or density clusters. So if clusters with different densities, For example, like here, data is sparse in this cluster, but in this case, the data is densely closed together. So here, when you conduct some maybe k-means clustering, the results can be like this. So we don't say this result is good good clustering. And also in this case also it does badly if the clusters have non-convex shapes. So let's say for this non-rounded shape data, the ideal case is two clusters can be grouped like this, but because it just measures some distance, the two center of the cluster can be calculated like this, so it can divide the clusters into like this. So this one is also not the good case. So the summary of this k-means limitation is it only works for rounded shape and equal size or density clusters, but still it's very good algorithms for clustering data. Yeah, so that's it for k-means clustering algorithms. So let me summarize today's lecture. So today we have learned one of the unsupervised learning, and that is k-means clustering algorithms. So here, k-means clustering algorithm is just an iterative algorithm to find some clusters. So here we just repeat the process until we find the proper centroid or centers of the clusters. So for that, we just use the average of points and just allocate and by doing this process iteratively, we can find some proper center of the clusters. Yeah, so that's it for today's lecture, and thank you for listening.